So next step is we're going to plug in the values into the quadratic formula. So here we have b is -1, a is 1.2, c is -25. So we have x equals -b, so that's 1 plus or minus the square root of b squared, so that's a 1, minus 4a, which is 1.2, c -25 over 2a. So use your calculator. We'll plug in. So we have 1 minus 4 times 1.2 times -25. So inside the radical, it's 121. So we have a 1 plus rad 121 over 2 times 1.2. Then you split it up into the two solutions. So we have a 1 minus 11 times 2.4, or x equals 1 plus 11 times 2.4. So you simplify it, we have a 1 minus 11 divided by 2.4. Oops, so you need to put the parentheses in the numerator in the top. So we end up with a negative 4.16 bar. So because we're working with items, so we can't produce negative items, so that's invalid. Then we have 12 over 2.4. We got x equals 5. So this is going to be our equilibrium quantity. How can we find the equilibrium price? So now we're going to plug in x equals 5. And which equation can we plug it into? Well, we can plug it into either equation, and you'll get the same answer. So coming back to the question, here we have the two equations over here. So we're going to just plug into the first one. We have p equals -1.1 times 5 squared plus 1.5 times 5 plus 40. Then if you simplify it, we end up with 20. So here we can summarize our answers. The equilibrium quantity is, then you look back in the question. So here it says that x is measured in units of 1,000. So you want to be careful about that here. The equilibrium quantity is going to be 5,000. And the equilibrium price is going to be $20. So in the next one, here it's also asking for the equilibrium quantity and price. This is for Bluetooth wireless headsets. So the first thing is we can set the demand and supply functions equal. Here we got negative 0.025x squared minus 0.5x plus 60 equals 0.02x squared plus 0.6x plus 20. And we move everything to one side. So we'll end up with 0 equals 0.045x squared plus 1.1x minus 40. Then we just use the quadratic formula. So we have x equals negative 1.1 plus or minus the square root of 1.1 squared minus 4ac all over 2a. Input, so we have 1.1 squared minus 4 times 0.045 times negative 40. So under the radical is 8.41, and then you get the square root of that. Here we get 2.9. So it's going to be negative 1.1 minus 2.9 over 0.09, or x equals negative 1.1 plus 2.9 divided by 0.09. Then we simplify it. So we know that this is going to be negative, so it's already invalid. The other one, negative 1.1 plus 2.9 divided by 0.09, we got x equals to 20. Then for the equilibrium price, here we just pick one of the functions. Let's pick the top one. So we got p equals negative 0.025 times 20 squared minus 0.5 times 20 plus 60. Then we just plug into the calculator. So here you can see we end up with 40. Then we can summarize our answers. The equilibrium quantity. So the answer is in units of 1,000 again. So here we got 20,000 headsets. And the equilibrium price is going to be $40. So next we're moving on into logarithms and also exponential functions. So for question 22, it says to write the expression 2ln A plus 3ln B as the logarithm of a single quantity. So 22, we're going to use the property we have ln A plus ln B equals ln A times B, ln A minus ln B equals ln A divided by B. So we got 2 ln A plus 3 ln B. That's going to be equal to ln A squared plus ln B cubed. So we use the property where you can move it to the power, and that will equal to ln A squared B cubed. For question 23, here it says to write the expression 1/2 ln x plus 2 ln y minus 3 ln z as a single logarithm. So we got ln x to the 1/2 plus ln y squared minus ln z cubed, and that will equal to ln, and then you multiply here, and then we divide the z cubed. We got x to the 1/2 y squared over z cubed. Then in question 24, it says to write the expression ln 3 plus 1/2 ln x plus ln y minus 1/3 ln z as a logarithm of a single quantity. So here we will take the ln 3 plus ln x to the 1/2. So first rewrite the factors in the front as the exponent, plus ln y minus ln z to the 1/3. Then we're going to multiply those additions. So we got 3x to the 1/2 y divided by z to the 1/3. So in question 25, it says to use logarithms to solve the equation for t. Here we have e 0.4t equals 8. So first thing is to write it in the logarithmic form. So we got 0.4t equals ln 8. T equals ln 8 divided by 0.4. So this is the exact answer. And of course, you can simplify it in the calculator. So we got ln 8 divided by 0.4. That's 5.1986. So for 26, here we got 1/3 e to the negative 3t equals 0.9. So first we can multiply the 3 over. We got e to the negative 3t equals 3 times 0.9. Rewrite it in the logarithmic form. So we have a negative 3t equals ln of 2.7. So t is going to be equal to ln of 2.7 divided by negative 3. And we end up with approximately negative 0.33. So use logarithm to solve 2e to the negative 0.2t minus 4 equals to 6. So first add the 4 to the other side. We got 10. Then we'll have e to the negative 0.2t equals 5. Negative 0.2t equals ln of 5. So t equals ln of 5 divided by negative 0.2. So if you use the calculator, you'll end up with approximately negative 8.05. So 28. Find the accumulated amount A if the principal P equals 2,500 is invested at an interest rate of 4% per year. T equals 10 years compounded semi-annually. So for this one, you need to remember a formula for the compound interest. So that's A equals P. And here it's compounded semi-annually, so we're going to use this formula, 1 plus R over N to the power NT. Then we plug in the numbers, so we have 2,500, 1 plus, so R is going to be 0.04, N, it's semi-annually, so N is 2. So this is for semi-annually. Then we have 2 times 10 years. So you can plug into your calculator and simplify it. Here we end up with 3,714.87. So in 29, here we're going to find the accumulated amount after 4 years if 5,000 is invested at 5% per year compounded continuously. So there's a formula for compounded continuously. A equals PE to the RT. Just plug in the values. We have 5,000, E, R, which is 0.05, and then 4 years. Here we got 6,107. So for question 30, it says to find the present value of 40,000 due in 4 years at an interest rate of 4% per year compounded monthly. So the compounding is monthly, so we're going to use this formula. A equals P, 1 plus R over N to the NT. And then if you want to solve for P, then we just make this power a negative NT. Then we can plug in the values. So here we have 40,000. 1 plus R, 0.04. Here it's compounded monthly, so it's going to be 12. And it's 4 years. So you simplify it. And then we got the value.